Hello, welcome back to my channel, JBTeguihanon, Engineering and Chemistry Tutorial. So today we're going to solve a problem. We apply the principle that we have been studying in the review that we had. So let's jump into the problem. And the problem says, I'll be reading it, a 2,000 kilogram automobile traveling at 90 kph, that is kilometer per hour. If you convert it to meter per second, that is 25 meter per second, hits the rear of a stationary 1,000 kilogram automobile. So it's hit another automobile which is stationary with a kilogram of 1,000 kilogram or kg. After the collision, the large automobile slows to 50 kph or 13.89 meter per second, and the smaller vehicle has a speed of 88 kph or 24.44 meter per second. Here's the question: what has been the increase in internal energy taking both vehicles as a system? So that's the question. Okay, what is the internal energy? So let's solve this. So what you do if you have this question, the first thing that you are going to do is, of course, internal energy is related to kinetic energy. So you have to solve first the kinetic energy. Kinetic energy is equal to, kinetic energy is equal to 1/2 mass, okay, of automobile times the square root of automobile. Of course, we're talking about automobile 1, right? So, and we plug in the formula, the value to the formula, 1/2. The mass of the first automobile is 2,200, and the speed is 25, so that is 25 square meter per second, and you get the kinetic energy in terms of joule, that is 687,500 joule, right? So 687,500 joule. That is your kinetic energy. Okay, or kinetic energy 1. Okay, this is your kinetic energy 1, right? Here we go. So after the collision, you have another kinetic energy, or we call it kinetic energy 2. Kinetic energy 2, okay, 1/2 mass of automobile plus, times velocity square of the automobile 2 plus 1/2 of the mass of B, and then square root of the velocity of the B2. Because we are going to account the collision of the two vehicle here. Okay, so sorry. What we need to do is wait. I don't have another slide, so blank screen. Keep. We need to have another one. Insert new slide. Okay, and then we use this one. Okay, so that we'll have a space to work with. So what we're gonna do is, of course, we are going to plug in the formula, the value to the formula we have. So what we have is 1/2 times 2000, that's the 2200, that's the weight of the first vehicle, and the velocity before it hits or after the collision is 89 square plus 1/2 of the mass of the second vehicle, or vehicle B, which is 1000, and then times the square of now his new velocity after collision. Okay, and we have the total kinetic energy after collision is equal to 51,900 joule. Okay, so we remember that the conservation of energy requires that energy 1 is equal to energy 2. The energy doesn't lose, no? You cannot create energy nor destroy it, so it transfers from one form to another form. So energy 1 is equal to energy 2, and energies, or energy 1 is equal to kinetic energy 1 plus U. That's the definition of energy. Kinetic energy plus internal energy is equal to kinetic energy 2 plus internal energy 2. Okay, therefore, what we have is energy 2 minus energy 1 is actually equal to kinetic energy 1 minus kinetic energy 2. Okay, and that is actually equal to 687, so 1000 minus 500, minus 510, 9,000. This is in kilojoule. So your U2 minus U1 is actually equal to, okay, 17600 joule or 17.6, sorry, 1760.6 kilojoule. Okay, so what happened here is that we use the principle of the conservation of energy. So the kinetic energy of the first automobile was absorbed actually by the uh, kinetic energy of the second automobile that is stationary. So energy, as we uh, recall, energy is related to kinetic energy plus internal energy. Actually, the energy is equal to kinetic energy plus potential energy plus eternal energy or internal energy. However, your potential energy is zero. That's why in here our kinetic energy, or sorry, our energy is equal to kinetic energy plus internal energy. So you have two types of energy: the energy before the collision, which is energy 1, and the energy after collision, which is E sub 2. So in the energy after collision, you have to account this guy here, right? This kinetic energy. Of automobile 1 after the collision, this is after the collision, and the kinetic energy of automobile B or 2 after the collision, because it's now have E velocity. Okay, so that's all for now. Thanks for watching. Please subscribe to my channel, JB Teguihanon Chemistry and Engineering and Chemistry Tutorials. God bless.